One of the key systems that helps control the water balance is the final cover system. So the final cover system, unlike the daily cover that's put on every day or the interim cover that's put on right when a cell is closed, is designed to be a permanent cover over the landfill. So in the picture, you can see there's some landfilling operations in the background. In the foreground, you can see there's a nice slope. It's grass, so that cell has been closed. That's final cover that would be applied. And then moving forward, one of the main systems that helps control the water balance is the final cover system. So unlike the daily cover that's being put on and taken off every day, or interim cover that's put on to a cell right after it closes, the final cover is meant to be a permanent system that stays there and protects the landfill until the end of its life. In the picture, you can see some landfill operations going on in the background. In the foreground is an area that would be completed with the final cover. So it's at final grades. It has the final cover constructed and it's vegetated, and that's meant to stay there over time and protect the waste underneath, keep the water out, keep the gas in, things like that. So you can think of the final cover system like the roof of the landfill. The main function is to keep the waste underneath dry, to conduct the runoff being generated by the landfill safely away from the mound, and also to contain the landfill gas and the odors and methane that come with that as much as possible to give the landfill gas collection system the best chance to pull it out of the landfill. Going to our Ontario regulation requirements, there are requirements for both how the landfill cover is graded as well as what it's made out of. So in Ontario, slopes must be 1:4 to 1:20. So to maximize the airspace, you end up having the 1:4 slopes on the sides and then the 1:20 slopes on the top. And you get these really prismatic looking landfills in Ontario and similarly in other jurisdictions. The required design in the regulation includes 15 centimeters of topsoil with 60 centimeters of cover below it. Often this is compacted clay, but it's not specified what it needs to be in the regulation. What it does specify is that cover needs to allow a little bit of water through. So it's not a complete dry tomb design. It specifies 15 centimeters of infiltration each year, and that's just to keep the biodegradation going at a kind of minimum and manageable rate and reduce the overall contaminating lifespan while keeping the gas and leachate under control. Now, many other jurisdictions, you'll see more complex covers that use engineered materials. So an example is shown just below that simple picture of the Ontario design, which features, instead of that cover layer or compacted clay layer, it uses a geosynthetic clay liner underneath a geomembrane. So two geosynthetic materials rather than just natural materials, and then a sand drainage layer on top of that. And this is when we get to the leachate collection system. It's kind of a leachate collection system on a smaller scale. So this kind of system would be designed to any water that infiltrates and hits that geomembrane will be able to flow away through the sand, and then as well any water running off the top would be able to flow, and then it's vegetated, so there's transpiration as well. Whereas on the Ontario example, it doesn't have that separate drainage layer underneath, so it would just be kind of the surface runoff that would carry the water away. So different designs based on the specific hydrologic and regular requirements of where you're building the final cover system. Some of the tools in your toolbox in terms of engineering this cover include, as we mentioned, natural materials like topsoil and clay, but also all these different geotextiles, or geosynthetics, I should say. So there's geotextiles and there's all kinds. Typically, woven geotextiles are stronger. Non-woven geotextiles have finer pores and are better as filter materials. So you'll often find geotextiles on the top and bottom of drainage layers to help contain the material and keep it from puncturing material underneath it and keep it from clogging with fines coming from the material on top of it. There's geogrids, which provide some tensile strength, and that's important for thinking about these slopes in the final covers. depending on the soil and the climate, you might want to make sure your slope has more stability with these types of materials. Then we've got the geomembranes, also called flexible membrane liners, that you might use to keep your waste really dry. It's this exact same material would be applied for liner systems, just you use a thicker one in the liner. So these have really, really low hydraulic conductivity, even compared to compacted clay. Geosynthetic clay liners. So these are, we know that clay has a really low conductivity and it's good for slowing down the flow of water. But a engineered clay that's comes packaged between two geotextiles is a geosynthetic clay liner, and it's just better quality control because it's manufactured and tested, and this is frequently put underneath a geomembrane as a self-healing backup layer. So a geomembrane, if it gets a hole, then it's got a hole, it kind of compromises it, whereas a geosynthetic clay liner, the clay will just swell and fill that hole again. So those often come together, and that's what's shown in this design on this slide. And then lastly, we have things like geonets and geocomposite drainage blankets, and those provide drainage in a smaller area, a cross-sectional area, than you would get with a comparative amount of sand or gravel. So a way to build more drainage into a smaller area, and then potentially cheaper if those materials are very expensive where you are. So we've got all these engineered materials that can be used to engineer the flows of water in the cover if natural materials aren't available or are expensive in the area where you're building. And I showed you the Ontario design. They're pretty standard. They're covered in grass and they're all the same slopes. There's different requirements in different jurisdictions. So some jurisdictions you're able to close with a turf product, which is what's shown in this picture. And then also you can do actually things on top of the landfill when it's done. So we'll talk about this a little bit later in site redevelopment. This picture is showing solar panels being applied on a landfill. So it's a really great place to put them. It's just sitting out in the sun all day. It just needs to have the right geotechnical characteristics to support those, as well as those hydrologic functions of the landfill cover. So those all go into engineering the cover system.